We're in checkpoint 2.23. They want us to find the measure of the angle in radians formed by the vectors A, which is 120, and B, which is 241. And they want us to round off in radians to the nearest hundredths. Okay. We don't need to draw this precisely on the XYZ space, but if we have the vector A and the vector B, let's say looking like this in some angle in space, we want to find the angle between them. We're going to use the formula for the dot product in terms of the angles, and that formula is that the dot product is equal to the magnitude of each of those vectors times the cosine of the angle between them, if the angle between them is theta. Now, for solving for theta, we would divide out by the magnitudes and take the arc cosine. So we're going to be left with something like this, or our computation will really just amount to figuring out what these values are, which is going to be the dot product and the magnitudes. So let's take the dot product first. A dot B, and A is 120, so it's 1, and B is 2 for 1, so 1 times 2 plus 2 times 4 plus 0 times 1. So that's 2 and 8, so that's 10. That's your dot product. Now let's take the magnitude of each of those. And if we take the magnitude, we're looking at some square root stuff. And 120, so square root of 1 plus 2 squared is 4 plus 0, that's a square root of 5. And then the magnitude of B is 241. So 2 squared is 4 plus 4 squared is 16 plus 1. And that's going to give us square root of 21. Okay, now we have the magnitudes. Our angle then will become arc cosine of the dot product divided by square root of 5 times square root of 21. And we just punched this in a calculator or some other program, and I did, and I ended up getting approximately, the number that I got was 0.219988. And if they want to specifically round off to the nearest hundredths, then we round off this 9th place, which we add 1, and so this will become 0.220 in radians. Okay, I hope that helps.